Okay, inverse relations and inverse functions. A relation and its inverse has the pair AB, and the inverse has the pair BA. Notice they flip. If a function passes the horizontal line test, then its inverse is a function. When a relation and its inverse are both functions, we say it's a one-to-one. Now this stands for inverse. It does not stand for reciprocal. The way we have found them algebraically is we switch the x and y, and then we solve for y. Now functions and their inverses have two special characteristics. They reflect across the line y equals x. And the other thing is that we already said it shared the points, but when you take the inverse of the function, and you compose it, you'll get x, or f of the inverse, and you compose it, you'll get x. And I already told you that AB is in one, and the other one has BA. So how are we going to do this? All right, in example 10, we have these 4 graphs, and we want to know if any of these graphs are functions. Passes the vertical line test, does not pass it, does not pass it, does. So these graph 1 and graph 4 are functions because of the vertical line test. Now I want to know if the inverses are function. So I do the horizontal line test. Yes, this inverse is a function. Yes, this inverse is a function. No, this inverse is not a function. No, this inverse is not a function. And that's how we get those. All right, let's look at example 11. We're going to find the equation for the inverse. Here's my original. I'm just going to write this as y. So now I'm going to switch it. I'm going to put, this is my original, and now I'm going to switch the x and the y, and I have to solve for y. Now remember, I could cross multiply. X times y plus 1 equals y. Xy plus x equals y. I can say x equals y minus xy. And then this is the step a lot of students forget. And that would be where I am going to factor out the y, 1 minus x, and then I'm going to solve for y. So that is now my inverse function. Okay? Now remember, not a reciprocal. It is the symbolism is for inverses. All right, now here is my graph. There's my f of x, and I want to sketch what the inverse looks like. I do not have an equation. So what I'm going to do is I'm going to sketch in the y equals x line. And then what I'm going to do is reflect that across. So if I flip it across, that means that my new graph kind of looks like that. And that is now my inverse function. Now I need to show algebraically that these are inverse functions. What I need to do is actually show f of g of x. Does that equal x? And does g of f of x equal x? If that's the case, they are inverse functions. So let's try this one. F of g of x. Well, let's put in our g of x. That's the cube root of x minus 1. Now I take my f function, whatever my input is, I cube it plus 1. So I take cube root x minus 1, cube it plus 1. What's the cube of a cube root? Well, it's just what's inside. And now these cancel and I get x. Now they told us it is an inverse function, so it should give us the same answer. Let's find out if that's the case. So now I plug in x cubed plus 1. Well, according to my g function, that is taking the cube root, whatever my input is, minus 1. That's what I'm going to put in there. So the cube root of x cubed plus 1 minus 1. Those go away, and what's the cube root of x cubed? It's x. So I have verified that those functions are inverses of each other. Alright, so now what I have here is I want to find the inverse function, and I have to look at the domains. Before I go anywhere, I'm going to look at the domain of f. The domain of f says that I can be -3 or bigger. The domain of the inverse is what I'm going to have to find out. Now, what's the range going to be? The range of f is going to be, if I put in -3 plus 3, I get 0. So I'm looking at 0 to infinity. Well, this range better be this domain. So let's find out. Y equals the square root of x plus 3. X equals the square root of y plus 3. To solve for y, I square both sides. So now I have x squared equals y plus 3, and I solve for y, x squared minus 3. That is my new inverse function. And my domain is going to be from 0 to infinity.